So dear students, today we shall start the 44 number video. Up to 43 number video it was given. Now we shall solve some problem by using inverse Laplace transform. So we consider this example. Find the inverse Laplace transform of log 1 plus 1 by s. Now we want to solve this. We consider this example. Find the inverse Laplace transform of log of 1 plus 1 by s. Now we have to solve this problem. This is a very easy problem. L inverse log of 1 plus 1 by s. Now we know inverse Laplace transform of derivatives L inverse fs. This can be written as minus 1 by t L inverse dts of fs. We know this. So L inverse fs equal to minus 1 by t L inverse dds of fs. So this is inverse Laplace transform of derivative. Now using this, if we write this minus 1 by t L inverse dds of fs. Fs means this whole is fs. This is fs. Log 1 plus 1 by s. We get this. Minus 1 by t L inverse and dds of log x. We know this formula of derivative ddx of log x equal to 1 by x. So this whole is x, then 1 by x. And this is using chain rule 1 plus 1 by s. We get this one. 1 by s. Now minus 1 by t L inverse, taking this one LCM s plus 1. If we differentiate 1 constant 0 and 1 by s means minus 1 by s square, because we know this formula ddx of 1 by x to the power n minus n by x to the power n plus 1. So here n means 1, 1 plus 1 is 2, minus 1 by s square. So minus 1 by t L inverse, this s becomes in numerator s plus 1. This is minus 1 by s square. We get this one. Now this minus cancel, 1 s is cancel, 1 by t L inverse 1 by s plus 1. If we calculate, we get this one. This one cancel, s plus 1 minus plus. Now this numerator is constant. We express in partial fraction. This is directly we can write 1 by s plus 1. And if we calculate this 1 by s plus 1, if we calculate this, we get s plus 1 minus s plus 1 minus s cancel, we get 1 by s plus 1. This is shortcut rule. We can use this directly, the difference of these two. Now 1 by t, taking L inverse within the bracket 1 by s, L inverse 1 by s plus 1. So we get this one. So 1 by t, L inverse 1 by s means 1, and this is minus 1t. Because we know this formula L inverse 1 by s plus a, this equal to e to the power minus at. By using this formula, a means 1t. Or we can write 1 by t 1 minus e to the power minus t. This is our answer. Next we consider another problem. So we consider this problem tan inverse 1 by s. Now L inverse tan inverse 1 by s, this one we want to solve. Again I rewriting this L inverse Laplace transform of derivative. The formula is that L inverse fs equal to minus 1 by t L inverse dts of fs. We know this formula. Now this is using this formula minus 1 by t L inverse dds of tan inverse 1 by s. This one we get. Again, you know in differentiation formula d dx of tan inverse x, this equal to 1 by 1 plus x square. We know from lower class, we know this formula. So minus 1 by t, L inverse remains same. This is tan inverse x, we assume 1 by 1 plus x square. That means you consider this whole is x, 1 by 1 plus x square. By using chain rule, we get 1 by s, we get this one. Now minus 1 by t, L inverse, this is 1 by 1 plus 1 by s square, and if we differentiate, this will be minus 1 by s square. We get this one. So minus 1 by t, L inverse, if we taking LCM, this s square LCM, s square next time becomes in numerator, s square plus 1, and minus 1 by s square. This minus plus, and s square cancel. 1 by t, L inverse 1 by s square plus 1. Now we get the direct formula. I rewriting this formula, L inverse a by s square plus a square. This is sin at. A by s square plus a sin at. Here a square means 1 square. This is a by s square plus a square sin a t, 1t. This implies sin t by t. This is our answer. So next we consider another problem. Now we consider this problem. Find the inverse Laplace transform of tan inverse 1 plus s. Now solution, L inverse tan inverse 1 plus s. We want to find inverse Laplace transform of this. Again we know this formula, L inverse fs equal to minus 1 by t, L inverse dds of fs. Inverse Laplace transform of derivative. This is a formula. Now this is minus 1 by t, L inverse dds of tan inverse 1 plus s. We get this. So I rewriting this formula, ddx of tan inverse x, this equal to 1 by 1 plus x square. We know this formula from lower class. So 1 by t, L inverse, this we assume whole is x, tan inverse x, then 1 by 1 plus x square. We get this one. And this will be dds of 1 plus s. By using chain rule, we get this. So minus 1 by t, L inverse 1 by 1 plus s whole square plus 1. This is the first, this one here. And dds of 1 is 0, dds of s is 1. We get this one. So minus 1 by t, L inverse 1 by s plus 1 whole square plus 1. Again you know first shifting theorem property, L inverse f of s plus a. So if we remove this a, then this will be minus at e to the power minus at L inverse fs. We know the first shifting property. So L inverse f of s plus a equal to e to the power at minus at L inverse fs. So this a becomes here minus at. So we assume this a means 1. We remove this 1. Then this will be minus 1 by t. This is e to the power minus 1t L inverse 1 by s square plus 1. So we get this one. Just we remove this. When we remove this a, then a becomes here minus at and we get fs. Now we remove 1, then 1 becomes here minus 1t and this. So this direct formula, L inverse a by s square plus a square, then this will be sin at. We know this. So this is minus 1 by t e to the power minus t, this one sin 1t. 1 means a. This is 1 square 1t. Or we can write minus 1 by t e to the power minus t sin t. So this is our answer. Next